Hey, welcome everyone out there in Audio Land to another edition of Pints with Ayre. I'm Brent Heffley, marketing sales for Ayre Acoustics. I'm here with Ryan Berry, our CEO and expert technician, and Ariel Brown, our VP and senior engineer. All right, how's it going today, guys?
Doing good. I'm on week 20 now, so with no haircut since the COVID thing broke out. So let's see how that goes.
You got to break out a hat.
Yeah, it's either going to be a hat or I'm sporting a mullet before long.
Bring the mullet back.
No.
Back. No, not really. Sweet. All right. Well, it wouldn't be Pints with Ayre without pints today, so I dipped into a little summer ale from Fremont Brewing. Get that out of the glare there. Fremont Brewing. Nice light summer pale ale. What do you guys got there? Anything exciting from Colorado?
So yeah, we're one of our local breweries from Sanitas Brewing in the city of Boulder. So one of their classic farmhouse ale.
That's
one of our favorites for several years now.
Of all time.
Yeah.
Yeah.
We need to send you out a shipment here pretty soon.
Right. Supply me until I can fly back there again.
There you go. Rent you a truck to take back and just load up.
Yep, for sure. For sure. Cool. All right. Well, as an excuse to have some beers, our topic for today is feedback. Feedback used in amplifier circuits or not in our case.
Yeah, one of our founding philosophies of Ayre, one of the core building blocks of Ayre.
Yeah, is not using feedback. So feedback was invented, what, 20s or 30s by Harold Black for AT&T to make intercontinental transmission lines work, so that you didn't have a bunch of distortion with the multiple amplifiers needed, which evidently worked great for that. But you know, we're not big fans of it for audio. It was popularized in audio in the 60s and 70s with a lot of the Japanese companies racing for the lowest distortion spec, when total harmonic distortion was like the thing. Like you get that down to 0.000000000
Star Wars numbers.
Star Wars numbers,
yep.
Then you obviously had the best product out there. And feedback allowed people to do that. So you lower the total harmonic distortion. But it's, you know, as we found, there are things that it does within the audio signal itself that aren't necessarily ideal. So why don't we talk about, you know, basically what feedback is, because there's positive feedback and there's negative feedback, and positive feedback's more in ecosystems and things that you'll find out in the world where
hopefully customer service,
something else, and you build that. What Ryan?
And hopefully customer service.
Customer service, positive feedback, exactly. So what's the best way to describe negative feedback to somebody who has heard the term but doesn't really know what that means in an amplifier circuit?
Sure. So negative feedback in amplifier circuit is where your input circuitry or any amplifier circuitry, you are comparing the output of the amplifier to the input signal to make sure that you are matching it. And if there's a difference there, if there's an error, then that error is then applied to the input signal so that it tries to get closer and closer to that input signal. So it is basically trying to minimize that error between the input and the output, and it's doing that constantly.
Okay, so I mean, it sounds a lot like, and it basically is kind of what happens with noise canceling headphones, right? You're taking some data from the outside, feeding it back into the input. You're flipping it in that case, and trying to cancel out that external noise.
Yeah. I mean, the case of noise cancellation, you're trying to actually cancel out a signal, whereas here you're actually trying to match a signal.
Right.
But it is the same, feedback path essentially.
Right. The same type of loop. that's there. So now you can do that in a circuit, what we'd say globally. So you took the very end of the output and the very beginning of the input and did a full global loop there, but you can also do it in small pieces internally.
Sure. I took many audio amplifiers as a complete product will have a few stages of amplification, like 2 or 3. And so global just means that you are feeding back the final output back to the original input of the amplifier. So that would be global feedback, whereas local feedback might be just around one of the amplifier stages within a circuit.
Right. So you'll find, there are people out there that will build products that are no global negative feedback.
Correct.
But there could be 1, 2, 3, any number of local
stages, that are using negative feedback. Yes.
In there. So
that's a really big distinction because, you can say no global feedback, which, is technically true, but it really kind of misses the whole point of stating that you have 0 feedback in your amplifier.
Right.
You have, multiple local areas that you have feedback implied.
Yeah. So now we know that the feedback was, at least in audio, originally kind of designed, or maybe it wasn't originally for that, but it became a specs number for total harmonic distortion. But are there other design benefits? Does it allow you to make a circuit more stable more easily, or does it have other aspects?
Well, I'll admit I don't have, having worked at Ayre pretty much my whole career, I don't have extensive experience with it, but my understanding is that no, it's actually, there's actually a few complications to actually applying feedback. You actually have, you have to have some frequency compensation to actually make sure it's remains stable when you add feedback. That actually applying feedback, which is essentially how an oscillator works, where you need this phase shift. And so you want to make sure that you don't have certain phase shift within your feedback loop that actually cause the amplifier to actually oscillate.
Okay.
So there's considerations you have to make when you apply feedback to keep it stable.
And it's kind of important to note what the feedback does, because it does reduce distortion, but in a specific instance, and that is during steady state distortion. So when you're doing test equipment and you're pumping 1K tone through something constantly, it will reduce that distortion, but music isn't steady state. I mean, if anything, it's the opposite of.
Which is why those specs would always say total harmonic distortion at 1 kilohertz. It would often give that frequency spec.
And that's one of those great examples of where, the measurements and what we always cite in, any review or, because it's the method that we have available to us, and it's the method that makes it easy to compare it to how things were done in the past.
Sure.
But it's kind of a flawed measurement in some ways, in the sense of it's not measuring what you're listening to when you're listening to music. Nobody's sitting in their room listening to one kilohertz or 10 kilohertz tone constantly and seeing how it sounds to them.
Right. I mean, I like 400 kilohertz myself.
Yeah, exactly.
Just background noise for.
Yeah, and so the other thing I'll point out is that even with a steady state signal, even with a sine wave signal in measurements, the more feedback you apply, one of the side effects is that the distortion characteristics change. The overall, THD plus N value will come down, but what often happens is that the lower order, so you have distortion often has is often described as the harmonics of the original signal that is added to the fundamental. So you often have a second and third harmonic, and those are often what you measure, and then you add up the totals to get your THD plus N value. And so without feedback, your THD is often dominated by your second and third harmonics. When you add more and more levels of feedback you often sacrifice those for higher order harmonics. And in general, over decades of listening tests and experiences, that the higher order harmonics are often less sonically satisfying. Those are often considered to be worse.
Right, right.
And that's the thing, I guess that's the biggest thing to take from it is, while it does give you those numbers, we know that adding the negative feedback does something negative to how the unit sounds. And the tricky part is it's not something that's measurable. That's easy to measure. It's something that it's a listen thing. And, it's easy for, us to say, oh yeah, it's bad and, we shouldn't use it. And that's just because that's the way we built our company. But the reality is we've tried feedback before. We had feedback in one of our products, particularly the AX5, VX5, and the codecs when they were first introduced, the 20 version of the AX5, VX5.
Very briefly, yes.
And the codecs all had feedback in them. And we had done some listening tests and we thought that it would make it sound better. And,
not the feedback itself, but not
the feedback, but the circuit design.
Yeah.
And it was working well. And so, we were like, well, it's maybe we were wrong about some things. And so we'll put it in and release the products that way. And, very quickly heard some responses. And, that really made us go back to the drawing board. Kind of stemmed from the Pono project that we had done prior to that. And, when we had designed the Pono player, we needed to put feedback in just for the manufacturability of the product. And then that kind of permeated into those other other three products. And, we were convinced it was going to sound better. And then people told us, no, it doesn't. And then we went back to it and took it out, spent, quite a bit of time re-listening to everything. And we're like, nah, they're absolutely right. But there was something wrong. And it ended up being related to that section where we added feedback to the circuit, pulled it out, and then updated every unit that we had shipped up to that point with zero feedback to get them back in the door and do the update for free to make sure that they were up to our standards, so to speak. And that was the only way to make it right. And so, it's not that it's just a feeling that, we started out, Charlie started out the company with zero feedback. And so we need to do that forever. It does involve, revisiting things from time to time, doing listening tests again. And it does confirm, that we're, that it's not the right thing to do.
Right. Yeah, absolutely. Absolutely. That's a great point.
Yeah, that circuit Ryan's talking about, we were trying to implement a DC servo to control DC offset to try and get rid of some manually adjusted trim pods,
right?
Which themselves, the quality of effect, sound quality, but also it's as far as manufacturing labor time and adjustability, they're a pain. They're kind of a necessary pain at times. And so that's what Ryan was talking about there. Now, I just want to jump real quick, to try and visualize what feedback is a little bit and visualize why, also as well as visualize why it doesn't make sense from our standpoint, is that, again, you are essentially generating an output signal and then looking at it, and then, if necessary, adjusting your input signal. Well, that takes a finite amount of time to actually, through that loop to make that correction. So you are essentially correcting something after the fact. Yep. You can't go ahead in time and look at it and correct it ahead of time. So you have to correct it after it happens. And so even just philosophically, that's you can't actually do that.
Yeah, you can see the flaw in that right away. And
nothing's instantaneous, so you are dealing with time domain questions there.
So even though theoretically that should happen so fast, as far as on kind of a light speed scale, as far as electrons pass and through that electrical circuit, it should happen so fast. under theoretically, some people think that that should not be audible.
Right.
Well, it's still, we still understand what exactly is audible to the human ear, and based on many listening tests, we know that it is audible, no matter how fast that you try and correct something after the fact. So it's again like our philosophy is just do it right the first time. Create a really linear, low distortion circuit from the beginning, and you don't need feedback.
Right.
The only reason for feedback is to reduce your distortion number, your distortion spec, and keep that and keep the the distortion products, the actual harmonics, the second and third predominant as the predominant harmonics.
Right. Right. No, that all makes sense, and it leads the question. Then it begs the question: why doesn't everybody do it? So, what are the challenges of designing without feedback? What are the things that stand in the way of any of other companies doing that?
Yeah. So, I mean, part of it is, I think there's some kind of mental threshold for people, like what is a acceptable number for that distortion spec that they have to print or publish.
Sure.
And so, and then how do you design? And then,
because you don't have a mechanism in place now that's going to go and clean up any mistakes that happen now.
Yeah.
Right. And then it is then designing a really linear, discrete analog stage. And so again, and this also predicates slightly on actually using a discrete circuit, because if you're using any kind of op amp, that pretty much requires feedback.
Right.
To get a usable gain, you have to actually, it requires the use of feedback. And so that's another reason why we don't use op amps.
Right.
And so designing a really linear, low distortion circuit requires very careful part selection. It often requires transistor matching. And so see that a lot of our circuits, we actually measure and sort and then create match sets to put into a circuit board. And so, to that end, most of our products, the input circuitry uses, the various, the Toshiba JFETs that were discontinued several years ago. And they're very linear, very ultra low noise devices. And they used to be, quite common, especially in Japanese and some of the high-end American-made audio products, but Toshiba several years ago decided that that product line, especially the through-hole parts, was not a viable business for them anymore. So they discontinued them.
A real example of they don't make them like they used to.
Yeah, that's one of the key parts.
There's nothing out there. I mean, we've hunted everywhere, and there's nothing out there right now that we've found that replaces these things.
Right. So we're one of the few companies that actually has a large stock of them. So we continue to rely on these really well made, very linear, low noise parts.
Mm-hmm.
To be able to make a really low distortion linear circuit without the use of feedback.
Yeah, so that's key, and I imagine the power supply is key too, feeding a great signal to begin with. And we actually do a zero feedback power supply. I don't know if other people do feedback in a power supply. Is that?
Well, yeah. I mean, a typical. At least as far as in the power supply, a voltage regulator, a typical voltage regulator, we use feedback. If If you buy like a 3-pin IC voltage regulator, yes, it depends heavily on feedback. And so when we design our own discrete regulators for use in the for use in our analog sections, we don't use feedback.
Mhm.
And so if you looked at that circuit in a vacuum, and it does not measure as well as a feedback-based IC regulator, just as our analog circuits have do not measure as well as a equivalent feedback-based circuit. But when we've done listening tests over and over and over again, when we've replaced any 3-pin base regulator with our own zero feedback circuit, it's night and day.
Yep.
Yeah, and I imagine that the circuit, the 3-pin chips are cheap. They're probably
Yes.
easy to use.
Usually.
Probably, yeah, they're probably fairly plentiful out there. And
Yeah, there's a wide variety of.
Sure.
There are plenty very expensive. Typically, ultra low noise is usually the criteria that many 3-pin regulators are based on as far as cost.
Interesting. So now we've talked fully about a lot about the analog section. Does feedback feature in digital anywhere?
At the core level, no digital. I mean, that's ultimately no.
Not really a piece for that. Yeah.
Well, that's the design end. The other end of the whole, zero feedback and the trials that we go through with it is, really in the production end of things too. It takes quite a bit of work for us, for example, with the DC offset end of things, not having any feedback there, where we have technicians manually set every trim pot for, every phase of the circuit to make sure that the DC is balanced to zero. We have to allow the amplifiers to get the full operating temperature, which takes a good day, to get up the full temperature, reset those measurements to get it, the bias and the DCs just right, because there is no feedback in the circuit that's helping us adjust or keep those at a certain level. So, it does take a lot of manual calibration. It's quite a time-consuming process that can, add hours to some of our products in the setup process and the testing. Before we're able to let it go out the door. So, there's quite a bit of tribulation to that.
Yeah, that's something I hadn't really thought about, in that extra time in production and QC.
Yeah, I mean, if it wasn't for the feedback setting everything just right in the circuit, we'd be getting things out the door in record time. But because each one is a labor of love, the DX5 was a great example. That product alone could take an hour and a half to 2 hours just to get properly tested and be ready to go.
Yeah. Wow. I mean, that's pretty huge.
Yep, MXRs they take a solid 45 minutes to an hour for each phase of the testing process. So there's 3 phases involved in the whole thing. And before it's ready to go out the door, there's a good 2 to 3 hours of testing and setup in there.
Right.
Now, another thing I'll mention is that and maybe we'll touch on this as far as another topic is our variable gain volume control scheme.
Right.
And that that variable gain volume control scheme relies on the fact that we do not use feedback. That would not work at all if we used feedback.
Yeah, we should definitely cover
It would
that.
actually defeat that.
One of the next videos we do is
That's definitely its own topic.
But yeah, that's a really good point. That design and all the benefits that come with it wouldn't be possible if we use feedback.
Yep.
Now here's a trick question for the call is, can you foresee any situation or any future product where we would use feedback? Is it something that if we decided we needed to make a $900 phono preamp or something, this feedback give us any benefits of trying to get to a lower price point or do anything there that we couldn't do without it? Basically.
Well, yeah, again, I would, again, relate to what Ryan was saying earlier with the Pono project. And so, our involvement with that was basically designing the DAC and the analog audio circuitry. And so Charlie and my original design did not use any feedback, did not use any DC servo, and it was DC coupled circuit. And so we actually had trim pots. And so when we threw that over the fence and they incorporated that and then they inquired like, well, how do we manufacture this? Well, you have to measure this and you have to adjust this trim pot. And they shook their heads and said,
nobody will spend that much time per product.
That's not going to fly. It's manufactured in some a Chinese factory, which I went over and visited and helped them troubleshoot some of their production line issues. But that kind of time and kind of manual adjustment was not an option. And so, if you're talking about a product, again, that was like a $400 or $500 product. And so when you consider the time that you can budget in labor to work on that, that's where you would seriously have to consider, and where we did have to incorporate there, at least a DC servo which is a form of which is a form of negative feedback.
Right. Okay.
So for an actual Ayre product, I can't say for sure, if we ever try to make a $500 product, that might be required.
Sure. So that's covers it a lot from a technical perspective. What would you guys say are the audible benefits of not having feedback in the circuit when you've done listening tests with and without? Like, what are some of the more noticeable things that come out when you're listening to music and you take that feedback out in one of the listening tests?
I think one of the biggest things that I noticed is if anything, it didn't sound as defined or resolute. It was more mushy in some senses. So it was, things kind of blended together that shouldn't have blended together. And it didn't have any of the, the punch, when cymbals came in, they didn't crash like they were supposed to. And, you could just hear the amp trying to fight these changes in the sound and trying to nullify basically what the music was trying to do. And that took away a lot from that feeling that it was, you were at the concert or you were at, listening to a performer standing in front of you. You got more of that sense of, okay, this feels replicated. And, it wasn't a pleasant experience in any way, and, feedback, again, just kind of go back, what Charlie said years ago was, it's trying to get rid of something that was put into the circuit, and it's trying to undo mistakes made in the circuit. And feedback it can't be perfect. If it was, amplifiers wouldn't sound different. That's the reality.
Yep.
And amplifiers obviously do. Anybody that's listened to different amplifiers in this world knows that no two amplifiers really sound the same. So that it's just not a case where feedback is a perfect solution to a myriad of problems that it introduces.
Yeah.
Yep. Yeah. Yeah, I pretty much agree. As far as that sound, it's really, it's it's first to me with feedback, it's found very, very, very strained and veiled. And when particularly the listening test we did where we compared regulators, either some IC based versus our own discrete, whereas it really, when we went to our own circuit without feedback, it became a sense of ease, veil lifted, and it was and just flowed much more naturally. So much more natural.
Yeah, I mean, it's more important to not have the problems in the first place. And,
Right.
you know, and it's not easy. It's you know, I got to applaud Ariel and Charlie before him, you know, on the amount of work that they've done, both, you know, individually and together, where, you know, it's trying to wrangle these designs and doing things where, you know, you know, a single op amp could do the job of these 10 components that you place on the board, and just, you know, everything that they do to make sure that, you know, the circuit is right. And then that negates our need for that feedback. But it's not an easy thing to do, and it takes a lot of time. It takes a lot of dedication to that type of design work. And I can understand the benefits of not wanting to do that, you know, particularly if I was trying to design, like you said, a $900 product. You know, it's a lot easier to do that when you can use a single component to do the job of what, you know, 5 or 10 components do, or you can, you know, minimize the size of the circuit boards that you're doing because you've squeezed everything into, you know, into less discrete parts, and, you know, you're more focused on getting those numbers. Whereas, you know, it's still not for us, you know, what you had asked before, would we be tempted to do that? After listening to the differences, I think we'd be really hard pressed, to be honest with you. It's just, it's not something that sounds right. And, you know, the AX5 experiment, the early 20 design on the AX5 really kind of cemented that in for me, where it's just like, this feels wrong. And I don't think it's something that we would be very easy to sell in the future. But, you know, it's really going to kind of depend on if we find something new that we haven't before, or we find a way to implement it a way that it hasn't been done before, where, you know, it suddenly works, but it would be difficult.
Nanotechnology.
Yeah, something. Yeah.
And to go back in time a little bit, because, you know, our circuit has, you know, kind of continually evolves, and we, continue to figure out how to ways to make our circuit better and better and better. And so I want to point out one is where we're working on the KXR, and so Charlie and I were, and this is when we actually developed the Equilock part of the circuit. And so when we added that and got that dialed in, and we were able to get distortion numbers to 0.001 on a particular test, and Charlie was really proud of that. And we actually called up John Curl, who is an old friend of Charlie's, and and because he actually wanted to tell John Curl that, oh yeah, we achieved 0.001% distortion with zero feedback. And John Curl was like, no way. There's no way. You couldn't have done that. And Charlie was beside himself. And so that alone was...
I'm sure the conversation was a little more animated than you're portraying it.
But Charlie, yeah. I remember a few animated conversations.
No doubt.
But yeah, I mean, from that earned a lot of respect from John Curl, one of the industry's probably most respected analog designers out there.
Yeah.
That was a big moment for Charlie, at least.
Yeah, so that's great. That's great.
Yeah.
Well, I think that's a great summation of zero feedback and where we're at with it. So, cheers to that.
Cheers.
And cheers to everyone out there in audio land. If you have questions or if you have positive feedback, because obviously we don't deal with negative feedback, you can email us at pints@ayre.com. I'll put it here on the screen. And until next time, happy listening.